Hello everyone, this is the beginning of our series, and what I want to actually show you is not a history. I want to show you the products that Checkpoint has, but we're going to go through history as well. We got to start with something, why not history? And let's just talk really quickly what is a firewall, and then we're going to go through the firewall evolution through years. Alright, so we have internet in the middle, hacker somewhere on the internet, and we have our personal computer here. So, and we have viruses, we have trojans, we have all kind of bad stuff that's going on in the internet. And we have a firewall that's standing between our personal computer and the internet. The purpose of the firewall is to basically allow trusted traffic and block untrusted traffic. Easy as it is, but really easy concept. But as we go through the firewall evolution, you're gonna know that those viruses, trojans, and hacks can be way more complicated. That's why a lot of vendors developed many products, and Checkpoint one of them. And let's begin. 1980s revolution in networking. There is a crazy rise in personal computers. This is where Ethernet was created, and that's where we were able to connect our local area network, to each other, each computer to each computer. So we were able to exchange traffic, and because of that, most companies actually link to each other. And because these companies actually knew each other, there were a really small need for security. It was unprotected, but we didn't even need, any security here. In 1990s, networking continued to evolve, and because of that crazy corporate PC usage, most of these companies started linking to each other more and more. That actually caused some people to become hackers as pranksters, just open CD drives, just small stuff. There is a minor need for security, but it actually started to stopping the production between these LANs. In 1990s, this is where WAN was developed, basically connecting LAN to LAN. At that time, it started bothering these companies that their production is being disrupted. So what happened? During that age, HTTPS protocol was developed, as well as SSL secure socket layer. We're going to discuss that later in our series as well. This is where Checkpoint invented their product, the firewall product, with the term "we secure the internet." Basically, the firewall that Checkpoint invented is called stateful inspection. Before that, there was packet filtering inspection, as far as I'm concerned, but Checkpoint actually during that time developed the firewall, stateful inspection. We're gonna go deeper in the next lesson how it works and what's the benefit of that. Apart from that, VPN was created, virtual private networking. So basically we connect. We actually, we're gonna go deeper into this later. Here is an overview what Checkpoint has in its arsenal. And antivirus, a basic signature filtering technique to catch viruses. In the new era, attacks became more complicated. Hackers started exploiting vulnerabilities inside of the applications. Let's say we have the browser, Chrome, Explorer, and we have Flash installed. What hackers started to do? They started exploiting their vulnerabilities. Here's an example of what they did. Let's say we have Adobe Flash Player, and we have that type of vulnerability. You can read that. They started exploiting the integer overflow in Adobe Flash Player, occurs in the copy pixel to byte. There is a lot of technical information. You don't need that. What you need to know that Checkpoint came up with IPS, Intrusion Prevention System, and IDS, Intrusion Detection System. The difference is prevention system prevents, it does not allow traffic to go to your network. IDS just detects it and creates a log. I'm going to show you actually the difference in our lab, how to configure that. It's not a big of a problem to switch between them. You might need that in case you want to tune that system. Or anti-bot. That's another feature that Checkpoint came up with. So basically what it is, if you have infected computer inside your network and it's trying to contact the infected server to send out some information that might be private in your company, Checkpoint knows it's forbidden communication and will not allow that and will block it. So, okay, 3 products that Checkpoint came up with at this time, IPS, IDS, and anti-bot. 2010. Internet is growing crazy and there are a lot of websites, there are a lot of applications. You cannot basically block all of them by using their IP addresses because they have a bunch of them. They spreading like a wildfire. So what we have in 2010, in that era, we have application control and URL filtering. I'm going to show you how that blade works. Okay, we have a guy sitting here right behind our firewall, and he's trying to go to the Facebook page over the internet. First, he's being authenticated via Active Directory, which is integrated with the Checkpoint Firewall. That blade is called Identity Awareness. Let's say we have IT group where John, Bob, and Mark. And so with application control and URL filtering blade, we can block specific action for the user, for that specific user, what to do with that website. Let's say we want to allow chatting for that IT group and upload files, but the rest, like download files, play games, and watch videos, we're going to block. So the IT group, when they try to connect to the Facebook, they will not be able to play any games. They will be only able to chat, let's say in a, I don't know, IT group chat. Same for marketing and other stuff. This is how Active Directory works. It's a whole different story. But the point here, Checkpoint can integrate with that product and integrate that with application control and URL filtering. Another thing here is it's not possible to block all IP addresses or allow them, rule them all. But with URL filtering blade, you can. So basically, the way it works, we have a category. Let's say it's finance. And in that finance group, there are predefined websites like Bank of America, Bank of Great Britain, whatever. So you have a predefined websites that applies to that category. Same, you can integrate this with your Active Directory. And just to summarize, 2019. So basically, right now, if the virus is not catched by any signature-based analysis products like IPS, antivirus, antibot, whatever, if the malicious file actually came through the firewall, what we can do, we can send the file to a sandbox solution. I'm going to show you how it works. All right, so we're trying to download a resume file from the infected server. We're making a connection there. The infected server replies back. It gets to our firewall. Instead of just sending us the file is being sent to the sandbox for the emulation, where it emulates the file in the virtual machine. And if the file is malicious, it's getting blocked. Usually that process takes up to 10 minutes. So in order not to wait all that time, Checkpoint came up with a solution that is called threat extraction. Once we have received the file from the infected server, it reconstructs the whole file from scratch instantaneously within a seconds, and our client gets a copy, which is not original copy, but it's cleaned and it's not malicious 100%. If your client wants to get original file, he just clicks get original in the link in that file, and if the file is not malicious in the sandbox, he's getting it from the from our emulation. If it's benign, allow. That's it. I'm actually going to show you how to set it up in our lab. It's going to be like bonus extra lesson in that course. Introduction to Checkpoint Technology. Hey everyone! So we're going to begin by discussing firewall and where it lies in the OSI model. And we're going to speak a bit about OSI model so you understand just the basics of networking. The next thing we're going to discuss is the difference between packet filtering and stateful inspection firewalls. By the way, Checkpoint and the stateful inspection. Okay. The last thing we're going to discuss is Checkpoint architecture. It might seem a bit overwhelming because too many components Checkpoint has, like smart event, like smart workflow, Cloud Guard, Sandblast, smart management, gateway. I'm just giving you things out of my head, but it's way more that Checkpoint has. I'm going to make it a bit way more simpler for you. It's not that complicated, I promise you, especially for R80 types of exams, CCSA related or basic networking skills and administrating skills you need for your job related things. All right, guys. Let's start by discussing OSI. The first layer is the physical one. This is basically where we have actual bits that come and go across the wire, like pulses of light, if we're speaking about fiber optics. The next thing is data link. This is where switches operate, where switches learn the MAC addresses of devices. And the second layer, when we speak about the second layer, we speak about LAN, about local area networking. We're not speaking about routers, we're not speaking about IPs, we're not speaking about anything at all but LAN, local area network. In the networking layer, we speak about packets. The packets what we have is IPv4 and IPv6. This is like basically if the packet is going out of the local area network. It's called WAN, somewhere far away where routers operate. Transport layer is basically how we send the packets. Types of segments that we use here is TCP and UDP. And we're going to speak a bit about this later on. Application, presentation, and session layers. We are not going to focus too much in this series because it's more of like, it might be related to programmers, not to us, not to networking and security type of guys. From the gap here, I guess you've already understood that Checkpoint lies between the data link layer and the networking layer. And to be more precise, firewall lies between the network card and the router. Yes, it kind of operates between those two, but it has its own perks. So we just get into the point how stateful inspection works. And here I have the really small, tiny rule base just to show you how it works. We have source, destination, there is like type of services we have to block, and the action. It's a bit small, but in the labs, we're gonna go really deep into this and how to set it up. All right, packet filtering. So that technology was introduced, I might be lying to you, but I think it was late 80s, maybe the beginning of the 90s. So the way it works, we have the firewall and we have to specify the rule base. The first rule to allow the client to the server, and the reverse rule to specify the connection between the server to the client. Okay, as you can see, I have the firewall here, and I put it right between data link and network layer. Yeah, just the way I told you, it's still here. All right, so the client tries to connect to the server, which is 909090, to the port 4433. These are two ports that my server is listening to. So what happens when client tries to connect? The first thing, it goes through the data link layer, through the switches and all that jibber jabber. All right, so then it goes to the firewall. The firewall, what it does, it checks the source, it checks destination, port, and the action. If everything is matched, what we're trying to do with our connection, then the traffic is allowed to the next layer and passes through the wire without any problem. So as I told you, in packet filtering firewall, you need a reverse rule. You need a connection back from the server. It will not work otherwise. You just have to do that. That's the technology. Don't blame me. Blame the the technology. All right. So another important thing you have to understand here is that anything that is not allowed will be denied. In this particular instance, I don't have the rule that will allow the port, which is 443. And I'm just showing, I'm trying to connect HTTPS slash 909090 443. Okay, we try to connect. First it goes through the data link layer, then it gets to the checkpoint. Oh, I'm sorry, not checkpoint, just firewall. It gets to the firewall, I'm sorry, typo. And it checks the role base, it's not there. That's it, blocks the connection. It's not gonna work. Because the action is denied by default. It's kind of some kind of implicit or implied policy, whatever. Yeah. All right, so before we understand how stateful inspection works, and stateful inspection is a proprietary thing, that Checkpoint invented. And before we go into that, let's just really briefly discuss how TCP connection works. Okay, so we have a client, we have a server. First, they have to establish a handshake. We send out the SYN packet, and we expect the SYN ACK packet from the server. Right after we receive it, we send out ACK. The second phase is the actual data that we send out through our connection, networking connection. It has download, ACK, upload, push, all kind of different type of flags that come and go. And the teardowns part, which is finish, acknowledge that, finish, and acknowledge that from the client side. It's a four-way handshake. The reason why we need TCP is basically to have a reliable type of protocol. If we lose data, it keeps the track of the packets that was lost and the packets that we actually received from the server. Same for the server receiving packets from the client. TCP is a connection-oriented communication, and it's reliable. It knows for sure, it checks out flags, and it knows what sequence number to expect, and that's why it's reliable. Yeah, and for a teardown session, it can be four-way handshake, it can be three-way handshake. They have to kind of like acknowledge that when they like client and server starts the connection. Yeah, same for teardown session. It could be different. Yes, that basically what I explained. It's connection-oriented communication. It's reliable because it knows what kind of sequence number to send. If it's a different sequence number, the server might assume that the packet was lost, duplicated, out of order, and it's going to drop the connection. And it's going to send again. It's like ACK. You kind of get the where I'm going with that. It's reliable protocol. When we speak about UDP, is basically the same thing, except for it's not reliable. That protocol relates to the fourth level of the OSAM model, which is the transport layer, and basically how the packet will be delivered. The difference between TCP is that it's connectionless. It has no handshake part session. It has no teardown session. It's not reliable. It doesn't keep track of the sequence number, doesn't keep track of the FIN packets, all kind of stuff that is in TCP session. It's not here. You might say it's not really useful because it's not reliable, which is not true, but it is actually useful. If you are into video streaming platforms or computer gaming, especially online gaming, not especially, only online games, and that's really useful because in TCP connection, if the pixel gets lost or you have a lag, you have to wait until you acknowledge the proper sequence number until you receive the correct bit of information. But in video streaming or online gaming, it might be too late until you actually get the proper packet. It will be too late. So in UDP, let's say you have like a bad pixel on TV, you don't want to wait for the right one because the picture actually changed, in so many different ways in each second. You get the idea, right? So you need UDP because it's fast, it's like not reliable, but screw that. Like we can see the picture, we can see the whole image. That's okay for us. It's way better in the sense of if we need to be efficient and fast. Stateful inspection technology. Okay, guys, so that technology was invented by Checkpoint, and it's used up until this day by almost 95% of vendors on the market. That's really interesting how it works, and it kind of like packet filtering firewall, where we specify the source, destination, port, and action, whether we want to allow or deny the packet. But the difference is we only need one packet. If we need to open up a connection from the client to the server, we only need one rule in the rule base of the firewall for the connection to work. You don't need the reverse rule, just like in packet filtering firewall. And I'm going to explain to you how it works. The client tries to open up a connection with the FTP server, and what happens is we send out the SYN packet. In our rule base on the firewall, we have the policy, source, client IP, destination, our FTP server, and allow the port 21, which stands for FTP protocol. All right, so we have that in our policy. It passes the traffic just fine, action allow. When the traffic comes back from FTP server, it goes just fine as well. It wouldn't work in packet filtering because you need a second rule. And here, I'm going to explain you how it works. To the right, we have a connection table. What connection table does, it keeps track of everything that comes and goes to the firewall when it's related to the network layer and transport layer. Let's say we have a client trying to open up a session with FTP. It sends out the SYN. As I told you, SYN packet has a lot of flags. It has a lot of types of sessions. The handshake session, the teardown session, when it's trying to finish the session, it has a lot of flags. And okay, so here's the packet flow. We try to open up the connection from the client to the FTP server. First, SYN is checked against the firewall policy, which we have allow. Then the firewall puts all the data for that session in the connection table. So here we have source IP, destination IP, all kind of type of flags that's related to that session. So once we open up a connection to the FTP, our firewall already knows, just like our client, what kind of acknowledgement we expect. So when the traffic goes back from FTP server, Checkpoint Firewall checks his connection table if that flag for that specific connection is allowed. If so, it allows the traffic. It checks it has all information related to handshake, data transfer, and tear down sessions. TCP is stored for 1 hour for 3600 seconds. If we have a scenario where in our connection, SYN ACK, like the reply from the server we expect, is different, it's not gonna go through the firewall. It's gonna be blocked. If we like step on the wire, if we try to modify the packet, modify the flag inside the our segment, it's not gonna work. It's not gonna go through the firewall because it knows what to expect in our connection table. Okay, so here's the scenario. let's say we already have established session between our client and FTP server. We have SYN, we have SYN-ACK and ACK. So right now we are in data transfer phase. We're sending data without any problem. We're getting all our good stuff from FTP. I usually get music. I'm not sure what you guys get, but anyway, so let's say we have a hacker somewhere outside on the network, and he's a man in the middle. He's trying to modify our session. He's trying to change maybe SYN-ACK, or maybe who knows what he's gonna do. He's trying to change the flag of our session. Oh no, he wants to send a finish flag, finish our session, but it's gonna be out of state. Checkpoint Firewall is gonna drop it out of state because that connection his fin flag connection doesn't belong to our connection. It's gonna be dropped. If he is trying to send his own data to the client, like pretend he's actually FTP server, so he can put some malicious stuff on our client side, it's going to be dropped because it's going to be out of state, because the type of data for that TCP connection he's going to send us is going to be different from what we expect, from what firewall expects from the FTP server. The sequence number in TCP session is not going to be exactly like 1 and we expect 2. It's going to be absolutely different. So it's kind of like it's going to be random number and we expect the following number. Let's say it's going to be 122 and we expect 123. But it's going to be different for each session. So that's why it's kind of impossible to guess. When we speak about checkpoint architecture, the first thing you need to understand, it is a device. It is one device that has some interfaces, that has a management port interface, that has a console port. What it does, it's facing the internet on one side and facing your internal network on the other side. Basically, we define a perimeter we want to protect. And how we do that, it's security engineer job to do so. So over here, there are different types how checkpoint can be implemented in your production or in your lab environment. So first of all, we have standalone. Standalone is basically when we have gateway capabilities and we have management server capabilities. Gateway includes everything that is related to access control. We block or accept traffic based on IP or a port address. And has other features like blocking based upon signatures, products like intrusion prevention system or antivirus, and so on. We're going to speak about this as well. And it has management server capabilities inside of that same appliance or virtual machine. It can be deployed either in virtual infrastructure or as a separate device. So over here on the screen we have actual device. 3000 model. I think it's 3100. I believe so. Alright, so the management server capabilities is basically we have policies we configure and we use it to push it to the gateway. All we do, we configure different types of policies and then push it to the gateway. This is called standalone. The connection and how we manage that, we install an application called Smart Console. In that particular instance, it's Smart Console R80, and we install it on a Windows machine and then connect that machine to our management server. In that particular instance, it's our standalone machine. With Smart Console, we connect to a management server and configure some policies that are being pushed to the gateway. The problem with that configuration is basically if your gateway goes down, you will not be able to manage that because your management server will go down as well, since it's in one box. If your management server goes down, your gateway goes down. It's pretty straightforward here. It's easy to deploy, but it has some downsides here. When you try to choose whether it's going to be standalone or a separate infrastructure, if you want to split gateway and management server, You perform that during the first time configuration, and we're gonna do that in our lab. Basically, how it looks like during the first time config, they ask you what do you want to do with that installation, whether you want to have security gateway plus security management. If you want standalone, just click check both products here, security gateway and security management. If you want only one, if you want to install gateway separately, you click only security gateway and leave security management unchecked. And on management server, this actual management server dedicated to manage 5 devices, 5 gateways. You basically check security management server and uncheck security gateway. And once you install that image, that ISO image, you're gonna have only security management capabilities. And this is called distributed scenario, where as you can see, you have gateway and management server split from each other. If your gateway goes down, you always have your management server on a backup, and you can install a policy to a new device, or somehow change the routing, change the policies that you might have screwed up, and reapply it to a gateway. If your gateway goes down, if your management server goes down, your gateway is still processing the traffic, and users are able to connect through your internal interface and go to the internet. Or if you have some servers deployed behind your gateway or inside your internal network, it will be accessible without management server. And during that time, if something happens to your management server, you have to think what to do with that. I guess that's pretty much it for the architecture. We're gonna be doing standalone in our lab, but during the first time config, I'm gonna show you where you can do that, where you can check and uncheck the features that Checkpoint has. In order to start working with Checkpoint and to actually install it in our lab, we need to get an ISO file from which we're going to be installing our operating system. There are 2 ways of how you can do that, 2 websites from where you can get it. The first website is called usercenter.checkpoint.com, and the second one is called supportcenter.checkpoint.com. The thing is, from usercenter.com, we're going to go to support and go to support center. And we're going to get to the same website I've just shown you, support center. But the reason why I'm showing you user center is basically because if you want to start working with Checkpoint infrastructure, you have to get used to these 2 websites where you're going to work a lot. Alright, anyway, so if you want to get to support center from user center, you go here and go for support and services, and then navigate to support center. Once again, it's the same website. You can just bookmark supportcenter.checkpoint.com. Okay, once you're here, you have a search bar, and first we need to find an operating system we want to install, an older version or a newer version. It's up to you. The latest version right now, it's R80.40, and we don't even have to look for it. It's right here on the screen. Checkpoint showing it to us in our face that unified security over 100 new features, and that's true. But not all of us want like the latest version for some reason. Maybe you have that reason. In order to or maybe you don't have that advertisement here. So how to find it? So you just type in the name of the version. You type in R80.40 in a search bar, and then you click enter. And the first line you're gonna see is the SK with that number. Don't really care for the number as long as you see Checkpoint R80.40, and it has a lot of stars rated by people. So once you open that, you're gonna see a whole page where you are able to download the latest version. You just scroll down, and in downloads you see clean install, and this version is okay for security gateway, standalone, or security management. I'm going to repeat that throughout the course, but let me say it. Security gateway contains all the features that Checkpoint provide, such as firewall blade, IPS intrusion prevention system, IDS intrusion detection system, all blades that are related to catching the malicious traffic or sorted by source to destination in a stateful way. Security management server contains capabilities of storing policies and then deploying these policies to security gateway. That architecture provides more security, and in case one device, let's say security gateway, goes down, you have all policies stored in your security management server. Or if your management server goes down, if you're not able to manage your policies, your security gateway is working absolutely fine without any issues. I will repeat that again if it's not clear. I just have to do that. And a standalone, this is where we have security gateway and security management server combined in one image. For the R80.40 version, it's the same ISO file for all of these three options that we have, and we decide what exactly we want with that image during the installation. So anyway, we click install, and you have to wait a little bit of time until we download 4 GB of Checkpoint ISO. The Smart Console is a fat client, let's call it this way, to manage our policies. Smart Console installs on Windows machine, and then we type in the IP address over the security management server or a standalone if you choose so, and then we are able to navigate, and we're gonna do that as well. So for now, just click install and Smart Console. In case you want any other version apart from R80.40, let's say you want a previous version, R80.20, you just type in the search bar R80.20 and go for it. You just click enter and go there, navigate to this page. And the funny thing is, for different versions there are different combinations how you can download it. For R80.20 there is a separate ISO file for security gateway and standalone, and separate ISO file for security management server. Let's check out for our 80.10 just for your reference, so you know there is a difference what version to download. In this course we will be doing a standalone. We're going to combine management server and the gateway capabilities in one standalone machine. And yeah, as you can see, for our 80.10 version there is only one ISO file. Okay, so let's download that and continue. The next thing is really important to know is to understand minimal requirements to install the Gaia operating system. It can be a bit tricky. So what do? You go to the support site, supportcenter.checkpoint.com. You see the search bar over here, and you have to type, look at this, you have to type first the version you're trying to install. Let's say we are installing the latest version, which is R80.40, right? And right after you do that, you have to do this, release notes, and then enter. Wait a couple seconds and then go for documentation tab right here, and look for exactly what I wrote, R80.40 release notes, and it's right here. Look at this, release notes. Then you click, and you're gonna actually there's a whole bunch of information what's been added to R80.40 compared to R80.30, and you can read all about that. But we are looking specifically for minimal requirements, and if you just search through the topics that we have here, we have requirements, we have open server hardware requirements, and that is exactly what we need. We need to click open server hardware requirements. What is an open server? Open server, Checkpoint defines that as a platform, not Checkpoint physical appliance, but anything else but Checkpoint physical appliance. It can be a virtual machine, it can be any server, physical server or virtual server, whatever, anything but Checkpoint physical appliance. So since we are doing our lab in VMware Workstation, it is our open server, and we have to check the requirements. So we click here, and right here we can see the type of component we want to install. If it's security gateway, or a security management server, or a standalone, where we have these two combined. As you can see, here your minimal system requirements you need to have. Okay, so we are doing standalone, right? In our lab, we need to have 4 CPUs. We need to have, as for the processor, it has to be that configuration, and minimum 8 GB of RAM. That information is really useful because there are different scenarios where you want to install your checkpoint. Maybe it's vSphere, and you have to ask your admin to dedicate that amount of resources to you, and here's your answer. If you are planning to do on other version, let's say it's R80.20 or R80.10, you do the same procedure. Look for R80 your specific version, release notes, and go for open server hardware requirements. We have to discuss the topology we're going to be having for this lab, and believe me, the topology that I have on the screen pretty much represents topologies that are in real production with real appliances. The difference is here we have a virtual machine, and in real life it can be either a virtual machine or a physical appliance. The topologies might get over complicated with different devices that are connected, but typically it's the same thing. A firewall represents a perimeter device that's facing internet and facing your internal network, and you as a network engineer, a security engineer, you define that perimeter. It's not really complex. You have, let's say you have 2 interfaces: external interface that is leading to the internet, and the internal interface that's leading to a certain internal network that you want to protect by your firewall blade. Remember, firewall is sourcing the traffic by filtering the traffic by either source or destination, source IP, source destination, or source port or source destination port. Alright, so why I have the host machine here? The next hop is not the internet, as you might think. In our virtual environment, it is the host machine. It is the host machine is basically because everything that you see in the blue, it's our virtualized environment we are going to be doing in VMware Workstation 15. We're going to have 2 virtual machines. We're going to have a virtual machine firewall, which is going to be our Checkpoint R80.40 version, and we're going to have a PC. We can use that PC as a management console. We can install a console and manage our firewall and management from our PC host, or we can just use it for testing to see if the traffic is actually getting blocked once we enable a certain policy on our firewall. It doesn't matter. It's a proper way to build it this way so you can see more functionality with that. But the next hope is our host machine. The reason for that is because my host machine is my laptop where I run my virtual machines. And this is the case. This is the more proper way. The next hope is not the internet. This is my host machine, because my host machine, once I install that operating system, my firewall is going to create a virtual interface on my host machine, which will be the next hop, and then the traffic will be routed to the internet. This is just a logical representation. So what you should get from this, we're going to have 2 virtual machines. We're going to have our 80.40 that represents our firewall, and we're going to have our PC. It's going to be either Windows 7, Windows 10, or Linux machine. It doesn't matter. The only thing it's going to do, it's going to be used for testing. All right. And during the lab, I'm going to help you with the addressing and what type of network adapter you should choose, whether to bridge it in VMware, whether to NAT it or include it in one subnet. We're going to talk about this as well. For now, just you need to remember it's 2 virtual machines and they are running virtually on our host machine, on our laptop. Alright, and now it's the time to actually install a Checkpoint in a virtual platform. We're going to be using VMware Workstation 15. I highly recommend, apart from Checkpoint, you install another machine to basically represent your internal network that is placed behind your Checkpoint. Something you can test with and play around to see if the traffic is going, between them, to see if you can actually block the traffic to a certain machine, and so on. I'm gonna be showing you exactly that. So first, let's install our Checkpoint machine. And in order to do so, here's our general page. We go for right-click in the left tab here, and we go for New Virtual Machine. Okay. We see welcome to a new wizard. What type of configuration do we want? Is it a typical or a custom one? Honestly, let's go for typical. No big deal here. The first thing they ask us is to provide an image, our ISO. That's what we have. We have downloaded previously, and I have it on my desktop. And let me do that. Okay, it's right here. Checkpoint R80.40. It's saying it's not able to detect my operating system, and I will do it myself. So what do you choose? You go for Linux, and you can choose Red Hat 5. Red Hat 5 Linux 64-bit. You can choose that. It will work just fine. As far as I remember, you can also choose Linux 2.6 kernel. It will work as well. I haven't done it for a while, so I'm gonna stick to Linux Red Hat 5 64-bit. Then go for next, and virtual machine name, I'm gonna do standalone, because this is exactly what I'm gonna do. I'm gonna have my gateway capabilities and management capabilities combined. You choose the location. It's your preference where you want to store that on your PC. Alright, so here the disk size. First of all, we're going to store it in a single file. No need to split it into multiple files. The thing about Checkpoint in real production, I do recommend you give it as much disk size as you can. We can speak about it a lot, why you need that. First of all, you need to store logs, especially on management server, and you just need that, okay? In your lab environment, just give it at least 30, maybe 40. It depends on how long you want to test that virtual machine. But the more you give it, the better. So I will give 30. Then click next, and over here we can customize our hardware. This is where it gets fun. Okay, first of all, we've checked minimal requirements, and they ask us to have minimum 8 GB of RAM. This is exactly what I'm gonna do. As for the processor, I guess cores will work just fine. If I say, let's say I have 2 processors and each of them has 2 cores, I believe system will take it as for CPUs. Do I want to use that? I've seen people use it. I've seen people don't. It's really up to you whether you want to virtualize Intel technology into your workstation, VMware workstation. I'm gonna leave it by default. I'm gonna leave it unchecked. And over here is our ISO. Alright, so as for the network adapter, we're gonna have 2 of them, because remember from our topology we have external interface facing the internet, and we have internal one leading to our internal network. So we're gonna add another one. We're gonna go for add and go for network adapter. All right, so now we have two of them, right? And that's the funny thing. What exactly I want to use, right? What exactly I want to use. Okay, network adapter 2 will be our private network. And as for the private network, I want to use my LAN segment. This is my local LAN segment. To create this, go for LAN segment, add, and create, let's call it private. Private network. Private network, click OK, and choose here. When we create a second virtual machine, our Windows machine behind our firewall, it's gonna have only one interface, and it's gonna have LAN segment with the same segment. It's gonna have private network, so they will be interconnected with that adapter. So, and as for the first one, honestly, it's not really much difference what we do here. Right here we can choose either a bridge network or a NAT network. In terms of firewall, in terms of the routing the traffic, it doesn't really matter. The only difference here, if we choose bridge network, it's gonna we will basically assign an address from our local network, same as our host machine from my laptop, and we will have access from our host machine. But if we use NAT, we will still be able to route traffic to the internet, but we will not have a connection from our host machine because the traffic will be NATed. Same as the traffic gets NATed when we try to go to the internet, it's being NATed by our router somewhere, in a closet. Alright, two options here, NAT and bridged. We choose NAT if we want to manage our gateway from our internal local subnet from where we have that access. If we use bridged, it's cool if we want to manage that from our host machine. What I mean by that, remember the FAT client, Smart Console, we have to install to manage our management server. In our particular instance, our standalone machine, we can install it on our host machine, on my laptop, and have access to my virtual machine through the bridged interface. And this is exactly what I'm going to be doing. And if I chose that, I could be using it if I install another machine and interconnect them. I know it might seem a little bit confusing, but it's actually not, and I want to show you that interconnection with these interfaces that we have in VMware. So look, if we choose bridged, we will have our virtual machine connected to our host without any problem, back and forth. It can be connected with other virtual machines through bridged interface, and with the internet as well. If we have NAT address, we are not able to connect with our host machine. This is the problem. So we're going to be using bridged to connect to our Smart Console from our host. But if you want to create another virtual machine where you will have Windows installed, you can use something else. You can use anything else that can interconnect your virtual machines. So in order to proceed with installation of Gaia, we need to click power on this virtual machine. Let's do that, and I'm gonna walk you through the installation guide. Okay, the first thing we see here is an option either to install it or to boot it from local drive. Software updates for VMware, no, for nothing. Okay, let's go for install Gaia on the system. Click enter and wait until we see more commands. Alright, the first thing they ask us if we wish to proceed with installation, and we're gonna click OK. Then choose a keyboard language, a keyboard type. Honestly, just choose your keyboard for whatever region it applies. I'm gonna click US. Okay, so over here it's really important to understand is how we decide how much of space goes to each partition in the system. The first thing I recommend is you increase the system root. You give it a bit more space. Let's try 9. And remember, if you are doing that, if you're installing it for the management server, give it more logs, because once you run out from logs, you're gonna have a lot of pesky error messages, warnings saying, hey, you don't have enough logs. Okay, so it doesn't really matter for that lab, so I'm gonna leave it like this and then click OK. The password, you can choose your own password. I'm gonna give a default password, VPN 123. All right, perfect. So over here, they ask us which port we'll be using for management. And most likely what we have here, Ethernet 0 and Ethernet 1. These are two interfaces that we have enabled. Let me show you to verify. Okay, we have NAT segment. I should have switched it to bridged, but it's all right. I will do it later. It doesn't really matter at this point. We can play around with this as well. And the second one is network adapter 2 LAN segment. And I believe Ethernet 0 represents to network adapter, and Ethernet 1 represents network adapter 2. I've decided that I will be using network adapter number 1 for my management. I will be using my host machine. I will install it right here on my host from where I will be connecting. So I'm going to choose Ethernet 0, and the next thing they ask is the IP address. So it has to be the same subnet, so my host machine is accessible, so they can interconnect each other. I'm not sure about the address. I'm pretty sure this is the subnet. It's most common subnet. Okay, so let's go in a command line and type in ipconfig to verify what address is given to my home laptop. Let's verify. This is the address. This is the address that I have, and the subnet is /24. So I will give 0.7. I think it's fine. Okay, 0. You do it the same way. You verify first. You verify your own host machine IP address, the subnet you have, and then you choose the address from the same subnet. The default gateway. So I can leave it like 1. And if I do so, basically the default gateway for my management interface will be my home router. Actually, I can try and choose my host machine as a default gateway. It will work just fine. So I can put 192.168.1.1 over here, or I can put this address. So basically what will happen once the packet try to go to the internet or somewhere else, it will connect to the virtual interface, which host actually knows about. That's the thing. Okay, but I'm gonna leave 1. They will be able to see each other anyway. Yeah, just click OK, next. And let's wait until it finishes. Then it gets to the stage where it has to be rebooted. And okay, let's wait and enjoy some good music. we have finished the previous video by installing a Gaia operating system, and at that point it's nothing. It's neither management server nor gateway or a standalone. In order to make it something, we need to go through the first time config. And the way it works, so we connect to the browser. And through the browser, we connect to any address that we set up for management during the installation of Gaia. And basically, we go through a step-by-step guide configuring our device, making it either management or a gateway. So right now, there is a point from where we connect. We can connect from our host, or we can create a new machine here, a new Windows machine, and set it up from there. I've decided that in that course, I will be using my host machine for management. I think it's more fun. It makes sense. And okay, so to start with, first we have to verify our network. So we have our login screen here. Okay, let's connect admin, and the password that I had is VPN123. I'm connected, and as you can see, the first thing that we see is, in order to configure your system, please access the web UI and finish the first time wizard. Alright, now let's check interfaces. The command to show all available interfaces is show space interfaces and enter. And over here we can see available interfaces. So if you want to have more information on each one of them, we get the command show interface and type in the specific interface we want to see. And the one I want is ETH0. So we have concluded, we have discussed that ETH0 is going to correspond to the network card, the first one right here. Anyway, so I just want to check it, and the address here is 192.168.1.7. And you know what? I've been thinking maybe that address is really close to what can be assigned through a DHCP to a devices, at home. Remember, this is my host. Let's go IP config. Let's check it. Let's check what I have. It's .5. Maybe my phone received an address .6, and my roommate received an address .7, and I might cause some confusion with that with that address. So I'm gonna change that. Honestly, I'm saying all of this to you is to show you a command how to change an IP address, but this is the proper way of thinking actually. So to change the address, the command is set interface. Then you can click tab, and it's gonna auto-complete the command. Set interface ETH0. Then I'm gonna tab again. It's gonna be IPv4, and I'm gonna tab 4 tab address, and I type in the address, and I want to make sure no one is using my address. And the address I will give 99. I'm pretty sure I don't have that many devices at home, so no DHCP server will give that address. Then we go for subnet mask, subnet, tab it, mask, and go for 255. Actually, you know what? You don't have to type all of that. You can tab, and you have an option to choose mask length, and then you go for 24. But I'm gonna do subnet mask. I'm an old school guy. I like that. 255, 255, 255, 0, and then click enter. So I will. I want to verify. Interface 0. The command applied properly. As you can see, now my address is 192.168.1.99, and it's showing the link is down. The state is on. That's good. The state is what is important right now. And there is a reason why the link is down, because we need to configure it properly. Anyway, right after you change anything via Clish, via CLI, you want to make sure you save the changes. So you go for save config. Save config. There you go. The next thing we need to do, we need to assign a bridged interface instead of NAT. This is what we've talked about in previous lesson, because if you want to be able to connect from your host machine to your virtual machine, you need to have a bridge connection. You need to somehow bridge your network and be able to have access from your virtual machine to your host and from your host to your virtual machine. Anyway, let's just change it here. But that's not enough. It's definitely not enough, because if I try to ping, let's say my router address is 192.168.1.1. If I try to ping it, it will not be able to do so. 1.1. And as you can see, the traffic is not going there. Apart from this, let's just verify. This is my host address. Let's try to ping it as well, to make sure I'm not able to ping it, okay? At that point, I hope you believe me. You see, it's not working. Host is not unreachable. Host is unreachable. So to fix that, what we need to do, honestly, there is actually another thing really worth mentioning. It's really cool if you know this stuff. So we're gonna go in expert mode. It's another shell that Checkpoint has to work with the operating system. First, to get there, we need to assign an expert password. Okay, I'm gonna do the same password, VPN123. VPN123. And then go for expert. Type in VPN123 right here. So what I want to do, I want to verify the traffic gets here when I try to ping it from my host machine, because it's going to be the same procedure when I connect to the browser via my host and try to access it. Same idea, different packet. All right, so the command is TCP dump -NNI from, getting on any interface, and the address I want to filter specifically 168.1.5. This is the address of my host. This is the address. Okay. Oh, forgot to type in host. Any interface, host, that one specifically. All right, we don't see anything here. When I try to ping it, and if it's working fine, I should be able to see something here. I will try to ping it. So you know what? I forgot the address I have. The command from expert is ifconfig. You can see all interfaces here with addresses. Okay, it's 199. Okay, let's run TCP dump again and try to ping that address from my host. 168.1.99. You see, I'm trying to ping, it's not working, and I'm having nothing here. What it basically means, the traffic never gets here. It's being misrouted, it's not even getting here. Okay, I actually know exactly why it's happening. That's what I want to show you. But it's actually cool. I'm showing you this whole procedure because once you do it yourself, you're going to come across different problems, and now you have some tools to verify where to look. Great start, great way to start working with Checkpoint is actually having mistakes and learn from them. And right now you're learning from my mistakes. It's even better. All right, so we're gonna go for edit and go for virtual network editor. Yes, we're gonna go this way. We're gonna go this far. We need to have admin rights here and click change settings. All right, so When you get here, you might see something like this. You might see NAT here, you might see host here, but I'm pretty sure you will not be able to see anything related to bridge here. And you want to make sure you have that. So you delete that. You go for remove network and add network. Let's go for VMNet 0 and taking some time to create a network. And we want to change from host only to bridge. Bridge to automatic. Over here you can see all your virtual adapters, your Wi-Fi adapter, your anything that you have installed in your host machine. You don't want to put automatic. I'm not even sure why it's here. It's ridiculous. Like how it's gonna know what I'm using. Weird. But anyway, so you want to choose your actual either a wireless adapter you use to connect to your network, or to use your patch cord, where you connect your Ethernet cable. This is what I use. I'm gonna choose that, and nothing else here. Just click apply and click OK, and then OK. Alright, so now let's verify if I'm able to ping it now. So just gonna rerun the TCP dump command and try to ping it again. Okay, there you go. We have traffic going on. Now we able to connect. The thing is, you will not be able to ping it back. If I try to ping my host machine back, it's funny. Come on, where's my mouse? Let me get out from here. Ping 192.168.1.5. I'm not able to do that, but the traffic actually gets to my host, and the reason for that is because of the Windows Defender or built-in firewall. If you have any antivirus solution, this might cause this problem. It's actually not a problem. Once you go and disable your built-in host firewall, it will ping either side. That's the thing. I hope it was informative for you, and now let's go on and configure connect and configure our device. In the previous lesson, we went through some troubleshooting steps to connect from our host machine to our virtual machine, and now we have to go through the first time configuration. So at that point, you should be able to ping your machine. I'm able to do so. I can prove it with TCP dump if I run it on my Checkpoint device. But anyway, I hope you trust me on this. Once you're able to ping it, once you're able to verify you have connection, you go to your browser on your host machine. I'm connecting to Edge, and I'm typing the IP address I've defined on my Checkpoint device. It's right here, 192.168.1.99. I have that, and you just type it right here with default port. You don't even have to specify a port here. I apologize, it's in Russian, but anyway, what it's saying, we don't trust the cert, and that's fine. What you want to do, you go for advanced and go to that web page. All right, and we are right here at our Gaia portal. The same thing as our CLI. We type in the same login and the same password, VPN123, and go for login. We can save it or leave it as you wish. Okay, and they give us a welcome message, Checkpoint first time configuration wizard. We're gonna click next. The first thing we do, continue with R80.40 configuration. Next. Here is the address that we have defined with our default gateway and subnet mask. We're gonna leave it as it is. This is the address we gave during the installation of Gaia. So next. They ask us which interface will be connected to the internet, and by default, honestly, by default it has only one interface, but honestly we can change this later, so we're gonna skip it and do it later. Okay, here's our host name. I'm gonna go and do standalone because it makes more sense. The primary DNS server, in our lab I will be using the public DNS server. Go for next. The time zone, You can do it manually or use NTP. I'm gonna stick with manual. Next. All right, so at that point, this is where it gets funny. So we can choose it's multi-domain server, or it will be either security or security management. If you're just starting working with Checkpoint, you most likely will not go for a multi-domain server. And if you are at the level where you work with multi-domain service, you don't even need an explanation on this. Basically, it's a server. It's a management server that can manage other management servers and deploy policies. But it's not what we're gonna do here. Okay, it's gonna be either security gateway or security management. All right. So and here, this is what I explained. If I leave both of these checked, we will have our standalone. We're going to have security management and security gateway capabilities on one device, on one virtual machine. When you do that on physical appliance, it's going to ask you the same thing. If I leave it like this, it's going to have only security gateway capabilities, and we will not be able to manage and connect to security gateway through our smart console. We're going to need another device, another virtual machine with that configuration, where we'll have only security management capabilities, where we're going to connect and then push policies to our security gateway. But I talk more about this in my CCSA course that is available here on Udemy. So, but the point of this course is to basically build a lab together, so you can practice on your own and play around with this. Anyway, we're going to do a standalone, do both of them. As for the clustering, if you want your two devices to be in a cluster, to have a redundant solution, and if one device goes down, another device takes over, this is one way how you can set it up right from the first time wizard. Usually it's not how it's done. There is a better way to do so. So I'm going to leave it unchecked. Automatically download Blade contract, new software, and other important data. Keep it checked, because it might seem like it's advertisement, but once you disable that, once you uncheck it, you're gonna disable a lot of implied rules, and you will not be able to connect and, let's say, get some signatures, and you will have to manually define an implied rule. I guess at that point it will not be called implied, it will be explicit rule, the rule that you create. But anyway, leave it checked, since you will have these ports opened automatically by Checkpoint. Then click next. Okay, so I can create a new admin with new password, but for me it's the same. I'm gonna use what I used, admin with VPN123. Okay, the next thing is from where we will be able to connect. And over here you can define a specific IP address from where you will be able to connect to your management server through your smart console, through your FAT client. You can set up a range, a network, a range or a network. But I'm going to leave as any IP address, so I will be able to connect from my external interface, from my internal interface, from my host machine, from wherever I have routing set up properly. Okay, next, and over here they ask us if we want to improve product experience. It's up to you. I usually say no. I don't know why, I just do. So anyway, and they tell us your device will be configured with the following products: security gateway and security management, primary security management server. Once again, I repeat myself, it's gonna install two products on one device: security gateway capabilities and management ones. So okay, we're gonna click finish and click yes, and now we have to wait until the process is completed. In the previous lesson, we went through the first time configuration and we made a standalone machine. We gave it a name, standalone. As you can see, it has gateway capabilities, and it has management capabilities. Right now, it doesn't have any blades enabled. You can see on that widget right here in the overview tab, because if they were enabled, they would be light up. They would be full in color. So they are not available right now, but we will do that when we go to the Smart Console, when we get to the FAT client and connect to the management side and install a policy. And policies include firewall policies, access control list, pretty much the same thing. Includes IPS policies, URL filtering, and so on. I talk about all of these and how to set them up in my CCSA course. But over here, we will discuss the point of our web portal. There is pretty much everything you can do that is available in CLI, especially in the beginner level. You don't need all of that when you start working with Checkpoint, but it's good thing you know important stuff, so you can, you know, move freely without any hesitation. So anyway, here's your general overview page from where you are able to download your FAT client, but this is our next lesson. We have widgets, we have system overview, we have blades, network connection, and throughput, how much traffic is going, you know, through our gateway. We can drag and drop it if you wish to do so. If you wish not to do so, don't do that. Anyway, so we move to network interfaces. Over here, you can see all available interfaces. If you click any of them, you click edit and you can change and modify. I've just connected to my, as an example, I've connected to my management server, to my management interface, and if I click edit, they're saying if I do any changes, I will get disconnected. It pretty much makes sense because I'm connected to this address. So don't do that unless you're certain of what you are doing. But once you get there, you have options. You can enable and specify the IP address. Then click OK, and that will be applied. If you want to add more interfaces right here, you have to go to your VMware workstation, go for VM, then go for setting, and then just choose more interfaces. Add another network adapter. It might not appear right away. Over here, you might have to reboot it. It might appear. I've seen it, various ways. Anyway, so over here you change your adapters. The next thing you want to make sure you know where it is. Here's your DNS server. This is where you set it up. Pretty easy, pretty straightforward. Then you have the routing, IPv4 static routing. This is where you set the routing to the internet from your local users and from the internet to, let's say, your freshly deployed server that is staying behind your firewall. This is where you do that. So far, we have only one route. This is the route we have set up during the installation of our operating system. If you wish to work with dynamic routing, such as BGP or OSPF, and so on, this is where you have it under Advanced Routing tab. Anyway, so you have user management where you can create different users. This is where you do that. So far, we have admin and monitor user. If we create another user, we give it a random name, and we can assign it a certain role. Then we go to the roles. And for that specific user, we can add features that will be available only for that user. Alright, anyway, there is another thing I really want you to be focused on. So over here under the maintenance, there is a shutdown feature where you can reboot the device. You can do the same thing via command line. If you type in the command reboot, it will automatically, not automatically, it's actually manually reboot the system. Under the upgrades, there is a feature called CPUs, Checkpoint User. I'm not sure how it's translated, but anyway, I call it CPUs. What we do here, we upgrade our system from different versions. Just because it's a fresh install, it doesn't have any valid license. It's given an error message saying it will expire on that date, and you're not available to check for updates. I believe so. It might actually check it, but it won't actually install new updates. You need to install at least a normal evaluation license, which will go deeper in the next lesson. Anyway, so this is where you do that. You just check for update, then it's gonna pop up the as you can see here, the list of our updates, and we choose what we wish to install. Anyway, that's the review of our web portal. That's all we do here. And in the next lesson, I want to go to the Smart Console, install our FAT client, and show you what it's capable of. Alright, perfect. So the next thing we do, we download Smart Console, a FAT client we'll be using to connect to our management server and manage our policies. There are two ways how you can do that. The first way, you get it on your Gaia portal. Once you connect here, over here in general overview page, you have an ad saying manage software blades using Smart Console. We can download it right here when you click it, and then save it to your computer. So we're gonna click save. It's gonna download it right away, right from the device. And the second way you can do it, you can get on support center.checkpoint.com and type in the version you have installed. In my instance, it's R80.40. We're gonna click enter, the same way as we would get Gaia, and go for the first link with a lot of stars here. Same where we got our ISO file. We scroll down to downloads and get Smart Console from here. We click here, we're gonna have the same image. I want to mention that if you have the version R80.30, you have to download a corresponding Smart Console. If it's R80.30, look up for R80.30 in your support center and get an according version of Smart Console. Anyway, so once we have downloaded that, then click run. And now we have to install it on our PC. It takes a little bit of time to check the integrity of the file, the hash sum and stuff. So just, it's pretty straightforward. Just next, and then we connect, and we will be able to actually work with our file. Now we connect to our management side. We need to type our username, it's admin, and a password, which is VPN123. That's what I have defined, and the server name or the IP address. And it's going to be the same IP address as we would place it here. So I'm just gonna copy that from here. So far, this is the only address I have on my device. And then we're gonna log in. We're gonna log in there. It's taken a little bit of time for the first time connect, and right after it's successfully connected, it's going to give us the fingerprint, so you can compare. Honestly, this is done for security reasons. There is a command in CLI where you can check your fingerprint, and if it matches, it's fine. You connect into a proper management server. Then we are proceeding. Perfect. We have successfully connected to our management server, and right away we see a screen. What is new in R80.40? You can read through that if you want to. I'm gonna close that, and I want to walk you through main stuff that's going on here, so we can start working with that. So first of all, we have our general page, which is called gateways and servers. This is where we have all of our management servers, all of our gateways that we are adding into our Checkpoint ecosystem. You can see the version of the device, you can see the IP that we have, the active blades, the hardware name. In our particular instance, it's an open server since it's not an actual appliance. This is CPU usage, how much CPU is being used, and recommended updates. Anyway, down below we have a status which saying license status is not activated, which we will activate. I'm gonna walk you through the process of licensing, and we can see our device, our memory usage, our CPU usage, and so on. On that page as well, we have a monitor options which we can click and see important information about our device, if it has any error messages, licensing issues, and so on, and the policy that's being installed on the device. Anyway, as you can see, it has a licensing warning saying it's not a real license, it's only a trial license, but we're gonna upgrade it to evaluation license, which you will be able to do so as well. Anyway, I'm not gonna wait for that. I'm not gonna waste time on this. Anyway, we're gonna move to our security policy. This is where we have what is the most important thing in Checkpoint environment. This is where we deploy policies. This is where we block traffic based on source or destination, or on a port, on source port and or on destination port. We have two types of policies here. We have access control, which includes firewall policy, access control list. It also includes URL filtering. We can block traffic based on its category. Let's say it's gambling. We can block a whole category for a specific user, for a group of users, you know, for everything we define here. We have a threat prevention policy. Threat prevention policies are everything that has to do with signatures, with some sort of attack. It includes blades like IPS, anti-bot, antivirus, threat emulation, and threat prevention. You can check this if you double click on the rule or click edit. You're gonna see all available blades that are related to threat prevention. Okay, so it's IPS, that's fully reliable on signatures, anti-bot, antivirus, same on the hash sum, that's being stored in the cloud, and then we download it to our device. Threat emulation, threat extraction. Anyway, as you can see, it's all right here, all our policies. Apart from this, we have a NAT section where we can translate the traffic based on source or destination. There are two ways how to do that. It's not that quick to explain. I talk more about it in my CCSA course. Anyway, so the next thing is logs and monitor. You're gonna use it a lot, especially if you're working, not especially if you're working with Checkpoint, you're gonna use it a lot. You go to logs and it has like a Google type of search. You can filter it by blade, you can filter by source, by destination, by port. However you like, you can filter your traffic and see if the traffic is being blocked or accepted, and see if your firewall is dropping the traffic, if it's accepting that. It's really important to be able to use it properly. So how it works, let's say you want to filter traffic to see, oh, as you can see, I don't have enough space anyway. Anyway, so let's say you want to Google, you want to try to ping 8.8.8.8. You just filter DST and that address, and you will be able to see all the traffic that's going on there. I don't have anything here since I haven't pinged it yet, but anyway, you see the point I'm trying to make. It has a filter. You can type it. You can filter it by blade. Let's try click blade, and then we choose firewall. It's giving us options what to choose from, right? We're gonna choose our firewall blade and see if we have any traffic here. we don't have any traffic here because we don't have a policy installed. By default, it doesn't have any policy. In order to first install the policy, make sure you go to your access control policy, and it's saying drop. You want to accept, because if you drop everything, you will not be able to connect to your device. And then click logging, so you can see the stuff in the logs and monitor. If you don't have logging, you will not be able to see anything. All right, so we have changed something, right? We have changed something in our policy. Right now, the device, the management server doesn't know about this. Everything that's happening right now, it's happening on in our FAT client. In order to push the information to our management server, we have to click the button right here, publish. Once we do that, all of these changes that we have made, it will be published to the database of the management server. Anyway, so we publish that, we update the database, but at that point, our gateway doesn't have the policy. Only our management server knows about it. In order to deploy that policy to our gateway, we need to click install policy. Okay, we click install policy, and there are two options we can choose from. We can install either access control policy. Remember, I mentioned this is the policy based on either host or destination, source port or source destination, or application or URL filtering. So right now we haven't changed anything to threat prevention. We're going to disable that and only install access control. Let's do that. Let's try and do that. Okay, so right here in the left corner on the bottom, you're going to see your progress, your policy installation progress, and see if it's being installed successfully or unsuccessfully. If there are any errors or issues, you're going to see a warning or a red cross where you have to see what's happening, what's wrong with your policy. But I'm pretty sure everything will be all right. Okay, perfect. We have installed the policy, and we can see now our gateway has a policy. We can actually try and play around with logs and monitor again and try to filter by blade firewall to see if we have any traffic now. Yeah, as you can see now, it's logging everything with the blade firewall. We can actually see the blade, the traffic is being accepted, what type of connection. We can open each packet to see what's happening, to see what's going on, to see a more detailed information on that. If we enable more blades, we enable the logging, and we can filter by more blades. Okay, another thing that is really important here is the object categories here, because if you're working with Checkpoint, you need to create more objects, more networks, more gateways and stuff. It might take a little bit of time to understand how it works, but we're gonna do that later when we try to deploy our Windows machine behind our Checkpoint firewall so we can test it. And the last thing we do in order to build a lab with Checkpoint, we install a device behind our firewall, basically in our internal network. I've selected a Windows machine I want to use to be behind my Checkpoint firewall. Okay, so what we want to do, we first have to put them in one subnet. In order to do that, okay, first let's go in Windows setting and move to network adapter. There's going to be only one adapter, and let's do a LAN segment. We're gonna do a private network and then click OK. So in standalone machine on our Checkpoint device, we're gonna do the same thing. It has two interfaces. The first one is bridged in order to connect from our host machine, and the second one is LAN segment as well. private network right here. Okay, so we're gonna confirm. Okay, they are interconnected with the one subnet. So what we have to do now, we have to assign IP addresses on these interfaces on both machines. So first, let's do that on our standalone machine. We're gonna do set interface tab ETH1 IPv4 address, and then let's do it from subnet 172.16.10. Let's give it address .1 subnet mask. It's gonna be 255.255. Pretty straightforward. Nothing special here. That's 0. Save config. And let's verify the interface. Show interface. Alright, perfect. So now we're gonna move to our Windows machine and assign an IP address from the same subnet. We're gonna go for Open Network Center, go for adapter setting, and go for our local adapter and change it to IPv4 address. We're gonna place static address 172.16.10. We can do 10. Same subnet mask, and default gateway is going to be our checkpoint device, the address that we have just set up, 10.1. As for DNS server, yep, let's give it in order to connect to the internet. Alright, perfect. Alright, perfect. Let's try and ping our default gateway. Perfect, I'm able to ping it. Now let's go for our web portal just to verify all of our interfaces are working fine. As we can see, the link status is up. If something is showing down or not connected, just just go edit and just verify it's enabled. Okay, perfect. So now we go to the routing just to verify we have all routes. We have a default route, which is absolutely fine. This is what I want to use for everything to get out of this to go there as default, but I want to add something else. I want to go for a destination and place my network 172.16.10.0 subnet mask. This is basically my internal network 255.255.0, and the next hop is going to be our IP address. Oh, no, sorry, not IP address, is going to be our network interface, Ethernet 1. This is where it belongs. And then click OK, and then save it. So this way, the gateway knows that this destination is behind that interface, Ethernet 1. Alright, so what we're gonna do now, we're gonna connect to our smart console. We're gonna update our topology for the management server so it knows about all of the interfaces and about the networks that are placed behind our interfaces. And we're gonna create a NAT rule so we can route traffic to the internet through our internal host. Perfect, we have connected to the smart console. What we need to do right now, we go to gateways and servers and click our main object. We click our gateway. We go here, double click it, wait a little bit of time until it's being loaded. Usually when you open Smart Console, it takes a little bit of time to load it fully. Then go for network management and click it. And over here, our interfaces are not defined. We need to define it. In order to do it, we click Get Interfaces with Topology. Then click Yes. And here are our interfaces. It has been automatically defined that this is our external interface from where the traffic leaves. And this is my internal interface. I'm going to accept that. And it's going to update the topology. All right, I'm going to click OK. I promise you that I will show you how to work with object categories. It might seem a bit overwhelming since there are a lot of objects, but the idea is the same. You create an object with which you want to work in a security policy. In our particular instance, it's going to be our Windows machine. So we're going to create here. We're going to go for a network object. We're going to go for networks. And we're going to create, actually not network, I want to create a host. I want to create a singular host. Network object. Let's go for, yep, you just click new and go for host. We name it Windows test. And we give it its actual IP address 172.16.10.10. Basically, that's the address. This is the address. All right. So next to what we do, we go for we go for NAT, and I want to apply network address translation. I talk all about it, how it works in different scenarios in my full CCSA course. Go for add automatic translation and go for hide. We're gonna hide our address behind our gateway so it will be able to route the traffic. Then we click OK. Alright, we have created an object here. We want to verify it's being applied in a policy. And as we go in security policy and access control, we can see the source is any, destination is any, so our object is there in any category. It's being accepted and is being installed on our device. So right now it's all on our Smart Console. We want to first publish that on our management server, and then we want to install the policy. We want to push the policy to our gateway so it knows it has that rule to accept anything and to translate 172.16.10.10 to a routable address in order for the host to go to the internet. Alright, perfect. It has been published, and now let's install it. Once again, we haven't worked with threat prevention yet. It's only access control. The policy has been installed, and now we move to our Windows machine. We go to our Windows machine. As I already can see that I'm able to access the internet. Okay, let's try to ping that address. Yep, I'm able to ping it. And as a last step, we go to our Smart Console in login and monitoring because we accepted log in tracking. We go there, Takes a little bit of time to load it. I want to be a little bit faster. But anyway, so in the source, we place our internal address 172. We can actually do not an IP address. We can source it by name. Just a little bit laggy. All right. I will just go for an address 172.16.10.10, and destination is, yeah, it's a bit laggy because it has a lot of traffic going on, and destination is that address. All right, there you go. The traffic is being accepted by Firewall Blade, and it's being added properly. Okay, this is kind of like one of the ways how you can start working and building your lab with Checkpoint. I hope it was informative for you, so leave your comments. It was a fun making this course. Thank you very much, guys. I appreciate it. Alright, so basically let me explain what is happening here. We are building a lab, but we are using something a little bit more complex and sophisticated rather than VMware Workstation. VMware Workstation is great if you want to build a lab between, in your on your laptop environment, and that's perfectly fine for training and stuff like that. But if you want to get on a little bit more professional level, or your company requires you to do a lab, I want to show you how to actually do that. And there are a couple features which are really useful and come in handy, when you work and on a real project where you have to deploy Checkpoint, a virtual machine behind it, test some features, and actually connect to that virtual machine without any problems. So the platform for virtualization that I'm using here is called Proxmox. It's free, and you can just download it and install it on your server, and then you can install Checkpoint and other machines. So it kind of works as any other virtualization platform. You can still use Hyper-V, you can still use ESXi, whatever platform you choose to work with. It's perfectly fine. The whole idea is going to be the same. The Proxmox platform looks kind of similar to all of them. So what we have here, we have Checkpoint in the middle. As always, it's our perimeter firewall, and we're going to have two interfaces. The first interface is our external interface with the public routable IP address, and it's connected to the internet. And we have our internal subnet 192.168.1.0, where we're gonna set up 1.1 for our Checkpoint internal interface, and for our Windows machine it's going to be .2, but they are in the same subnet. So I'm using Proxmox where I install Checkpoint, and on Proxmox platform I install my Windows machine. So they are interconnected by the virtual switch. So the whole idea here is, because I have the public IP address, I need to be able to somehow connect to my virtual machine here, because I want to use that virtual machine for my further testing. I want to see how the traffic is going through the firewall, but at the same time I want to be able, to see that actually for myself. I want to connect there. I want to be on that machine. So I don't want just to log in from the terminal. Maybe I don't have access. I need some remote access. So I'm going to show you how I use mRemoteNG software for that. It's a free software that you can use for that purpose. Personally, my favorite. Or you can use just a regular RDP client from any Windows machine. So with that knowledge here, with that topology knowledge, let's continue, and let's start with the very basic step in our virtualization platform. Alright, over here I have my Proxmox platform, my virtual environment, where I have all of my machines which I will be able to interconnect. and I'm gonna create two machines here. The first machine will be our checkpoint device, checkpoint firewall, which is gonna have two interfaces, and the second machine is gonna be our Windows machine, which we will connect through our checkpoint firewall. So to start with, you need to upload an image which you download on Checkpoint website, which you go for and type in the version that you need to install, whether it's R81 or R80.10, whatever the version is. You just go there and download that. So once you download the ISO file, you go for storage on your virtualization platform, and then you have to upload it. In Proxmox environment, you go for storage, your local storage, and go for ISO images. Over here I have my various images that I have used for installation. So basically I use the button here, which is called upload, and I have uploaded Checkpoint R81 image, R81 ISO, which I will be using for my installation. So the next thing you do over here, to the left, on the left tab, we're gonna click, right click, and gonna do create VM. So once we do that, we're gonna choose a node where I am installing that. Typically, if you have a new installation, it's gonna be one node. If you have an already working environment, it might be more, depending on the environment that you have. So then you're gonna have to click the VM ID, a random number, which will be associated specifically with that virtual machine. So as for the name, let's call it Checkpoint Firewall. Checkpoint Firewall. I think it's a good name, probably without underscore. So then we have to choose the operating system, and we have to choose our ISO. So let's choose it. Let's choose Checkpoint R81, and as for the type of the machine, it is based on Linux, so we can choose that parameter. So this is fine. Then we click in next, no graphical card, and as for the SCSI controller, we can use an older one. Let's use this one. Let's try this one out. So as for the hard drive, let's give it a little bit more of size, of disk size. So I will go for 150. So and the next thing we do, we can choose the format as, you know, it's pretty much anything. So I'm using a default one for Proxmox. So let's go for next, and the amount of CPU. So I prefer to use in about 4. So we're gonna use 2 cores and 2 sockets. Should be more than enough. And as for the memory, I want to use in about like 10 gigabyte of memory. So that should be fine. So as for network, first I will use my external interface, and we're gonna talk about interfaces a little bit later. Once I create that virtual machine, I will show you where it's done. The idea is pretty much the same for any virtualization platform. You create a network interface which is connected to a specific subnet, right? So by default, you're gonna have to set up a subnet which is connected to the internet, which is routable. So this is something I will create. I'm not quite sure exactly what was the number, you know, for external communication with the network, but I think it's this one. But we will check this out later. For now, we just need to select that there is no VLAN tag. We can disable firewalling, Proxmox firewalling, I want to mention. So the next thing, we just confirm. So okay, I will just confirm, and for now what I want to do while the virtual machine is created, I want to disable all of my working machines so they don't utilize the resources, because I want, you know, to use all of my resources specifically for Checkpoint for now, without any Windows machine. We're gonna do that later. That's all good. So over here we have our Checkpoint firewalling, and we can verify and see our configuration. what we have here. So as of now, it doesn't work. It doesn't work because I haven't started that yet, but that's all right. So let's go over that. So over here we can connect to a console later once we started. Over here we can see an arrow saying, hey, we're not able to connect since the machine is not running, since the machine has not started. So over here we can modify and change the value for memory, for CPU, for our SI controller, and in the rest. And we're actually gonna add more network devices over here. So that's why I have mentioned that I'm gonna come back to that. So let's actually go and check out the networking parameters. I'm gonna show you the virtual switches and like what I do there to operate there, because it might be a little bit different on various virtual environments, but the idea is the same. So if you don't know how to create a virtual interface, how to create a network interface, you just have to, like, let's say, look it up. You have to say how to create a virtual switch in a specific environment. If it's ESXi, you say creating a virtual switch in an ESXi environment. If you are using Citrix environment or Hyper-V, you can replace the word. But I think it's pretty self-explanatory what you have to do here, so kind of obvious. Let's move on. Let me show you the networking, how it's done in Proxmox. The first thing you need to do, you need to first get into the nodes where you have your name, and then find a network system configuration file parameter, and I have it right here. The nodes, then you go for system, and then you go for network. And over here you can see a bunch of interfaces, and some of them have IP addresses. The IP address that I have over here on VMBR0 is basically the address I'm using to connect over here, right? So this is the same address I use in my browser, to connect remotely for my Proxmox to manage all of that ecosystem, right? And over here I have my gateway, is to basically where I move the traffic in order to get to the internet and get out of here. So I have used that one as my external bridge, so I'm going to be using that address to get out from here. So this is my next hop for my checkpoint environment, so I'm going to use that as the external interface. So right now I need to create an internal network. As I've mentioned, in our internal network, we're going to be using that subnet, which is 192.168.1.0, and I already have that over here. Right here is, let's rename it. Let's go checkpoint internal environment. So we don't need any gateways here. We don't need any IPv6 addresses here. It can be auto start, it's fine, we can check it. But the subnet, the IP address that we put here should be like that. We put a whole subnet. So we're gonna use VMBR3. We have to remember that because this is what we're gonna be using over here. Okay, so let's just click OK. Let's click OK, and we need to apply configuration over here. Let's go for yes. Takes a little bit of time. It's done. Okay, so next we have once I showed you that, we're gonna go to Checkpoint Firewall and go for our hardware. In our hardware, let's go for add, and we're gonna add a network device. And as a network device, we're gonna add VMBR3. VLAN tag, no, we don't have to specify any VLANs, so, and we just add. So over here now we have two network devices, net0 and net1, and as a subnet in which they are located, net0 is located in a bridge which is connected directly to the internet with a gateway address 5.104.228.1 to get out of the internet. So I'm using that as my external interface over here. So this is my external interface, and when I actually deploy a machine, I'm gonna use that address to manage my checkpoint device sitting right here, remotely. Okay, so once we have done it, what I want you to do, we need to start the machine. We're gonna start the machine. Takes a little bit of time, and we can open a console, or you can go for open it from here, from this tab. And then we're gonna install our operating system. Alright, we have logged in to our Checkpoint device, and as you can see in our web console, we have a lot of buttons here, a lot of stuff where we can click to. But what is really important, we're gonna connect for network interfaces and finish off the our network configuration. So we have Ethernet 0, which is working just fine because we are able to connect via that IP address. And in our Ethernet 1, we are gonna insert the address, which is gonna be this address, 192.168.1.1. So let's do that. So right here, we're gonna click edit on our Ethernet 1, and we're gonna go for that address, 192.168.1.1, and subnet mask is 24. So we're gonna enable that. But right now it's not connected anywhere, but that's all right. We're gonna actually interconnect another machine with that. But before we actually do that, what I want to do is to download a thing, our FAT client, which is called Smart Console. So let's do that. Let's click over here, download now. And we have already done it before, but it was for the version R80.40, and you have to remember in Checkpoint environment, the version of the console has to match with the version of the system where you are connecting. So just a random Smart Console will not just work with that specific gateway. So we need to download the version Smart Console for R80, R81 specifically. So let's do that in the next video. We can download our Smart Console via Support Center from Checkpoint side, but we can also do it from here. Right here in our overview, in our general tab, in our web console, we're gonna go for Manage Software Blades using Smart Console, and then we're gonna click Download Now. So let's do that. Let's click it, and then we're gonna install it. So okay, I'm gonna click Save. Takes a bit of time because of the weight of the application. So once it's downloaded, I'm gonna click and install it. The process is really simple, just next, and then we will be able to connect to our device and actually manage our firewall policies, our blades and stuff like that. And actually, let's complete the installation. I will just fast forward that so you don't have to wait all the time, and then we're gonna go for the fun stuff. So in the next part, we are going to install Windows machine and then connect it to Checkpoint. The reason why we need a Windows machine behind it, we can actually have a different platform there, but we need some machine which is in our internal network, which we are protecting by our firewall. So we define a perimeter. So that machine will be in our perimeter. All right. I already have a Windows machine installed here, but I actually want to show you really quickly how you do that here. So you right click, create VM, you specify the VLAN ID. We can go for random number over here and give it a name. We're gonna go for Windows machine test. I'm not actually going to install it because I already have it installed. It's just for your reference, so you know what I have done. So you have to choose your storage from where you get in the ISO file. You go for ISO and choose your Windows, and then you go for next and go for the installation. And let's disregard that. Let's close that. I hope it makes sense at that point what I'm doing here. And over here in my Windows environment, I'm gonna go for hardware because I have already installed that. So let me check that. Let me check what I'm having here in my Windows configuration. In networking, I have VMBR1. So I want to make sure this is, oh, this is a different machine. So actually I can use that one. It's a lot of machines that I have here, VMBR1, but I want to use 192. So actually I'm going to use VMBR4, which we have. Oh, actually not that one. It's this one. It's VMBR3. It's Checkpoint Internal Environment, something that we have created. So I want to use that one. So let's move here and remove that one and add another one, which is our VMBR4. 3. I apologize, 3. I'm gonna click add. And we're gonna start that machine. So we're gonna start that machine, that Windows machine, and I'm gonna go for a console and see what is happening there. So start Windows normally. Now what we have to do, we need to go for our network interface and change the IP address. The IP address will be 192.168, and I can already guess that you already know the address. I use that one all the time. So let's switch the addressing here. 192.168.1.2. This is the address that I have here. Let me show you the topology. This is this address, 192.168.1.2. So okay, and we are moving here. 192.168.1.1. This is our Checkpoint default gateway, and then we're gonna click OK. So we're clicking OK, and now we have to verify. Oh, it actually doesn't matter whether it's work or home office, doesn't matter. So we're gonna open CMD, and we need to be able to ping. Oh, let me change the language here for English one, and let's ping. Jesus, the language changing all the time, so let's go for English again. So let's ping 192.168.1.1, which is our checkpoint, and we are not able to do that, maybe because of the policy of Checkpoint. Let's see if we are receiving that on Checkpoint side. So we have to go into console, but I actually want to enable endless ping so it doesn't end. So let's just cancel that. Let's go for T. So it's gonna ping forever until I end it. So now we're gonna go for Checkpoint environment, and using TCP dump command, I want to verify I'm actually receiving packets here. So this way I know for sure that, you know, I have connected my subnets properly. So okay, let's go for admin, then I go for my password, and over here let's run TCP dump command. So yes, you have to first log in into Expert. So so what you do, you go for Expert, but before you do that, you have to set Expert password. You're gonna go for the password, and then you're gonna go for Expert. And let's go for TCP dump. So for the port Ethernet 1, and host from where we expect the traffic is this one. So, and we can see traffic coming here from that address. We can see pings coming here, but it means that we have set up our network properly. The problem here is we don't have a policy to accept our traffic, and the packet is being dropped. The command to check it out is this one. Let's go for Yes, the command is fwctlz debug drop, and we're grabbing for that address to see if the packets are dropped. And as we can see here, the packet is dropped because we have a default policy rule. That's why it's being dropped. What we're gonna do, we right after we log in our smart console, we're gonna change a configuration and specify our policy properly. Alright, and the next thing we're going to talk about is we have a Windows machine here, and we need to interconnect it with our Checkpoint device, right? So, but because we don't have a policy right now, we are not able to even ping it, and we have checked it in a previous lesson, in a previous video. So the ping is still going here. So what we're going to do, we're gonna go for our smart console, and the first thing you need to do, we have an object over here. We need to double click it, and in that object, once it is opened, we're gonna go for network properties, and we have to tweak a couple things. And the first thing, we need to check out what is happening with our networking. Even though we have set it up, and we have set it up properly, so we might have problems here. So let's check it out. Let's check it out, and it is really important to always consider that, regardless of whether it's your first installation or you've been working with Checkpoint for some time. It's always to check. It's always a good idea to check it out. So here in network management, you can see your interfaces. But over here, you can also see the topology. Basically, the topology is something that you define behind an interface. You can say, hey, here's going to be my internal network behind Ethernet 0, and there's going to be an external network behind that, interface, for example. But over here, as you can see, by default, it's unidentified, undefined. So basically, you have to define it, right? You have to select what it's going to be. If it's not defined, it's going to be dropped, regardless of whether you have a security policy or not, and it's going to be dropped because of the anti-spoofing rule, because we don't know what to expect from that interface. We don't know what subnet should actually get on that interface, so that's why we are dropping that. Couple of things that we can actually do here is the first thing we do, we click get interfaces, and it is basically grabbing and fetching all the information from our device, from our gateway, and it should actually recognize whether this interface is external by looking at its IP address, and recognize what is this address, whether it's internal or external. So we just click get interfaces, and we do get interfaces with topology. If it doesn't work, we have to manually click and define the interface, define its priority, right? Define where what side it is facing. So we're gonna click get interfaces with topology. Let's do that, and over here we can see, okay, so it was defined properly once we actually perform that procedure. So we can see that this interface, this address, has the external direction, and 192.168.1.1 interface has internal direction, and that's fine. So once we do that, we will not have any problems with our anti-spoofing. Once we do that, let's give it a quick second. So now there are no issues over here, but if you do have any problems with get interfaces with topology, you can always double click it, edit a specific interface, get in there and do it manually. Anyway, so I have done it, and until I actually publish and install a policy, no configuration is applied. This is how Checkpoint works. We have to first publish it. By publishing that, we actually updating the database of the management server, and when we install a policy, we fetch that information from the management server and install it on a gateway. Even though we have a standalone device where we have a gateway which processes the traffic, and the management which has all the policies on one device, even though we have them on one device, we still have that structure where we have to publish it first from our smart console, and then we have to install it on our gateway. How Checkpoint calls it is three three-way architecture, because we have three components: smart console, we have smart management, and we have smart gateway. So anyway, so I haven't applied it yet because there is one thing I want to do. So if we go for security policy, this is where we actually perform either allow or deny blocks, or allowness, I guess. So we either allow traffic or block the traffic based on its IP address, based on its name, or other properties like ports, services that are used, or something else. By default, we have a policy which is by default is drop. It's not a magic how to do that. There are a lot of rules, there are a lot of guidances how you can actually do that. But the implied rule by default, and for a security reason, should be drop. It should be the last rule always. So first we allow something, and if our specific connection didn't hit an allow rule, it will be dropped by a default rule, which has to be actually logged, even though it's gonna require a lot of traffic, but it's good practice to always log it. But over here in our lab environment, I'm gonna select it as accept, so I can connect my Windows machine without actually too much thinking. So we can sort things out over here, so and understand that this was an issue why we are not able to connect it, why we are having drops. So I have selected as accept, and for lab reasons it's fine, but if in real production you don't want to do that, because the whole idea of a firewall is when you have this rule as denied, and you want to deny pretty much everything unless you want to allow something. This is security, so this is the whole point of security when we talk about firewalling. So okay, I have selected that as accept. We have logging enabled in case I want to see some logs, and let's install the policy. When I click install policy without pushing here, we're gonna have an option here right away, which is publish and install. So we're gonna click publish and install, and in 1 second, maybe 2 seconds, maybe okay, I'm just gonna take checkpoint words for that. Take a moment. We're gonna wait for a moment while it's being published, and they're going to ask us what kind of policy we want to install, whether it's going to be access control policy or it's going to be threat prevention policy. A threat prevention policy is all security blades, everything that is related to signature based analysis, like IPS, like antivirus, or like sandboxing. So everything that has to do with checking out whether the feature is malicious or not. Alright, let's install the policy. I'm gonna click install button over here and wait until the installation process is complete. Usually it takes a couple minutes, should be faster since we don't have too many policies. Alright, perfect. We have installed the policy, and now is the time we actually go on our Windows machine and see if we are getting any traffic. And as you can see, the traffic is getting there, and you can see the traffic was running all the time. Now it's working perfectly fine. We are able to ping our device, and our firewall is accepting that. Alright, and the next step I want to do is I have my Windows machine here, and I want to be able to connect to the internet via my Windows machine. So we're going to console to that via our terminal, which is kind of uncomfortable at that point, and I will show you later how to do that. So if you want to connect that machine via Checkpoint, what you have to do, you have to go for your smart console, and over here in our networks. So to get here, you have to first get on the first page, where you have object categories, and then you go for network objects, and then followed by networks, and we have to create a new network, and then you create a network with the address where your Windows machine is located. So as you can see, my Windows machine has the address 192.168.1.2 in the subnet mask 24. Right, so what we are doing next is basically creating that network. that subnet, and we have to go for NAT. In the NAT section, we're gonna go for add automatic address translation rules, and it should be as hide. So what's gonna happen? So everything that is going from the subnet 192.168.1.0 subnet mask 24 and is trying to leave through our firewall will change the port on our external port for its external address, and it's gonna leave with that. Right, so it's going to leave with that IP address, which I have 5.104.228.7. So this is the address which will be used for translation with a random chosen port. All right, then we're going to click OK, and then we're going to go for publish and install the policy. So once we do that, we can go to our Windows machine, and we will be able to basically interconnect with the internet. Let's try typing a random number. Okay, as you can see, we have a connection. Everything is working perfectly fine. Let's try maybe pinging. Sometimes ping is not the best way to check out the connection, but anyway, let's do that. Okay, now we have a connection, and what I want to do, so we're gonna go to the logs and monitor, open a new tab, and we're gonna filter by source 192.168.1.2, which is my Windows machine, and destination is 8888. It should be different tab. Should be just logs. Let's go for logs and type in the same filter and see if we can get any information from Checkpoint side. As you can see, you have a lot of requests, a lot of echoes going for that specific destination from that source. Echo requests. It means the traffic has passed the firewall because there is an accept rule. We only have one rule at that point, but that's all right for the purpose of education. Alright, so right now I'm able to connect to the internet via that Windows machine, but it's here in terminal. I want to be able to actually connect remotely for that Windows machine. And in order to do that, I want to actually use the rule and NAT rule, and destination NAT rule on Checkpoint to connect to my Windows machine. So the first thing you have to do on your Windows machine, you have to open up a remote connection configuration. Let me show you where this is. You have to go for computer, right click and go for properties, and you have to open RDP. You go for remote settings from here, and you go for allow connections from from computers running any version of remote desktop, right? So you can use a default, then you click OK. You can use a default RDP client, or you can use an application that I have here. This is called mRemote-ng. It's a great RDP tool, which is way easier to use than regular RDP client, but this is just my own preference. I'm gonna show you how to do it here, but you can use any RDP client as you want. So let's go for our Checkpoint configuration, and over here, in order to do that, you have to create a new rule in security policy, then go for NAT, and then over here on top, you go for add rule above, and we're gonna create a new rule, which is we're gonna call it to Windows. Let's do actually RDP to Windows. So any source can connect. Our source, original source, can be any address. It can be anything. Original destination. So this is where the client is actually trying to connect to the original destination. So the original destination that the client actually gonna connect to is our Checkpoint address. This is gonna be this address, 5.104.228.7. Because from the point of view of the user, the original address is this one, and the translated address is something that Checkpoint translates. So this is the original destination, where the traffic is destined for that address, because this is routable on the internet. This is our Checkpoint address, and we are going to do that on our external interface. And service, over here we can choose any service, any port number that will be used. And let me show you how to do that. So we can actually create a new port, and to do that you have to go over here and go for services, new, more, service, and we're gonna create a TCP port, and we're gonna give it a random number. Actually, it doesn't matter, so we're gonna call it win port. It's alright if we don't give it any name. So we're gonna, I mean, like proper name. It doesn't have to be called TCP, whatever, something. You still have to paste something here. So in port, we're gonna let's go for 5,000. You know, you can choose any number really. So we're choosing 5,000, and in advanced, you don't have to click anything actually. So we're gonna go for OK. We just created win port, and we're gonna add that win port. Oh, it's actually used somewhere else. So let's go for, okay, let's go for 555. Hopefully it's not used anywhere. Used. Okay, let's go for another port which is not used. Okay, 11,000 is not used anywhere, so that's what I'm gonna use. So let's go here, and we can actually type in 11,000 like that, and over here we have win port. So this is our original packet. This is where the packet is destined to, so it's gonna go for 5. Okay, I'm actually gonna show you later. So, and translated source is gonna be original because we're not translating any source. And as for the destination, what we are doing here, we are translating it for the address, which is our Windows machine, and we have to add it here because we don't have that machine here. We need to actually add it. We have a network where the Windows machine is, which is 192.168.1.0, but we need to have our Windows machine defined specifically. So we're gonna go for new, then we're gonna go for more. No, actually host. We're gonna go for host, and over here let's call it win machine 7. Okay, let's give it this name, and over here we pasting the Windows address. We are not gonna NAT it because we don't need it, so we're gonna click OK. And the I've just created here, so I want to paste it in translated destination, so we're gonna paste it here, and we're gonna translate the service to our RDP. So let's put RDP here in the filter, and we have remote desktop protocol. So we're gonna use Microsoft RDP 3389 port. It's already here, so we're gonna click that. And once we have that policy over here, what I want you to do, I want to push the policy and then install it, publish and install the policy. So it's gonna take a couple of seconds, and then we're gonna go for our mremote ng and paste all of the necessary information, so it's gonna make way more sense. We have just finished policy installation, and let's go for our RDP client. So we're gonna go for connections, and we're gonna create a new connection. So let's go for new connection, and we're gonna call it Windows 7 checkpoint. So in the protocol, instead of 3389, which is default RDP protocol, we have to paste 11,000 because this is our original packet, which is not translated. So as our IP address, we have to use our checkpoint address, which is this address. So let's just copy it from here because this is where we are connecting. So we're gonna copy that address and paste it right here. So as for the actually, you know what, I don't remember the name of my user, so I guess I have to check it. Let me really quickly check what's the name of my, should be admin actually, but that's fine. Maybe it's Eugene. So okay, we will try something out. We need to connect there. If you know the username or password is wrong, we can always play around that. The thing with testing here is how we are able to connect. So I have it here. So let's try Eugene. It's good. So the next thing is our password, and let's try perform a connection. Okay, perfect. As you can see here, I'm able to connect. Unfortunately, I don't have my wallpaper here. For some reason, it's not there. Let's paste it here so I can see palms over there. So as you can see now, I'm able to connect via my Checkpoint device. And now you know how to do that. Now you know what address you have to paste over here, which is our external IP address of firewall, and we use our port 11,000. So on the Checkpoint side, how it would look, you go for a security policy, and over here our original destination is the address 5104.2287. Original service is 11,000 because this is how the client is generating the packet, and as our translated destination we're choosing our Windows machine address, which is in our internal network 192.168.1.2, and as a translated service we are using default RDP port, which is 3389.